The learning target for today's notes is I can prove that two figures are congruent using the definition of congruence. So to prove that two figures are congruent using this definition, we have to show that all corresponding sides and all corresponding angles are congruent. To do this, we're going to have to use a new theorem that we haven't used before. So our new theorem is the third angle theorem. It says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles must be congruent. So this makes sense because we know that the angles in a triangle have to add up to 180 degrees. So if, for example, I know this angle is 60, that means angle K is also 60. If I know angle B is 40, that means angle J is also 40. There's only one possible number left for these two angles that will make the triangles add up to 180 degrees. So that third angle would have to be 80 degrees. So we will need that theorem when we're writing these proofs. So we will do two of these proofs together, and then you can try the last two and come back and check your answers. Our steps for writing these proofs. The first thing we need to do is rewrite and interpret the given information. And that means we need to mark up our diagrams. We need to show which sides are congruent and which angles are congruent. After we've done that, if we don't have enough information to prove that our figures are congruent, like we don't have all the corresponding sides congruent and we don't have all the corresponding angles congruent, the next thing to do is look at our diagram. There might be some vertical angles that we can use, or we might have a reflexive side. So it's been a while since we've talked about all the properties and theorems that we use in proofs. So let's take a quick sidebar and talk about the reflexive property. So our reflexive property says anything is equal to itself. And the example that we see most common is that like A is equal to A. When we're looking at proving that figures are congruent, where we will see this reflexive property is if we have two triangles that are kind of stuck together. So if I have these triangles, A, B, D, and I have triangle B, D, C, this side in the center is part of both triangles. That side would be our reflexive side. And I could say that side BD is congruent to itself. Okay, once we have interpreted all of our given information, we looked to see if there was any information on the diagram we can use. We write our proof, and the very last statement in our proof is what we're trying to prove. So let's start our first example. The first thing I'm going to do is read my givens and mark all that information on the diagram. So we are given that angle Q is congruent to angle R. We are given that P is the midpoint of segment QR. We are given that NQ is congruent to SR, and NP is congruent to SP. Now for this given, I didn't mark anything on my diagram yet. That given tells me P is the midpoint of QR. So here's P, right in the middle of QR. If I have a midpoint, I know that point is right in the center. So what that tells me is that these two sides have to be equal to each other if P is the midpoint. So this is a given that we had to interpret. We had to think about what that information was telling us before we could mark it on our diagram. So now, using all my given information, I can see that I have 3 pairs of congruent sides. So that's taken care of, but I only have 1 pair of congruent angles. So now I'm going to look at my diagram and see if I have any vertical angles in here. And we do. The angles on either side of P are vertical angles. And now we have 2 pairs of congruent angles, which means I can use my third angle theorem to say that my last pair of angles are congruent to each other. So now in my diagram, I have shown that all my corresponding sides are congruent and all my corresponding angles are congruent. We did the heavy lifting already. Now we just have to take that information that we used and put it into our proof. So our proof always starts with the givens. So we know angle Q is congruent to angle R. We know P is, I'm going to abbreviate, the midpoint of segment QR. We know that segment NQ is congruent to segment SR, and segment NP is congruent to segment SP. And all of that was given. The next thing that we marked on our diagram was that segment QP is congruent to segment PR. And we were able to mark those segments as congruent because we were given that P is the midpoint. So our reason here would be the definition of midpoint. And I am abbreviating all over the place. The next thing that we included on our diagram were our vertical angles. So when I label these angles, the one on this side would be angle NPQ. And we are saying that's congruent to the angle on our other side, which is angle SPR. And we knew those angles were congruent because they are vertical. So I will say definition of vertical, and I'm going to abbreviate just by using the symbol for angles. Now the only thing left in our proof that we haven't included yet is that angle N is congruent to angle S, those yellow ones. And we said that was true because of our new theorem, the third angle theorem. So now to make sure that I've got everything that I need, I am going to check my proof and make sure I have 3 statements that say pairs of angles are congruent and 3 statements that say pairs of sides are congruent. So in the givens, I have an angle, pair of sides, another pair of sides. Our third pair of sides happened in statement 2. So we got all of our sides. In statement 3, we had a pair of congruent angles. And in statement 4, we had a pair of congruent angles. So we're good. We did the thing. We have 6 congruent statements here. Now the only thing left is to write our proof statement. We were trying to prove that triangle NPQ is congruent to triangle SPR, and we did. We know that those are congruent because we used the definition of congruent triangles. We are going to try one more proof together, and then you are going to try the last 2 on your own. So if you flip to the back, we're not going to do the first proof here. We're going to do the one in the middle. So we are trying to prove that triangle DEF is congruent to triangle GEF. So I'm going to start by diagramming all of my given information. We are given that DE is congruent to GE, DF is congruent to GF, angle D is congruent to angle G, and angle DFE is congruent to angle GFE. So from my given information, I can see that I have 2 pairs of congruent sides and 2 pairs of congruent angles. From my diagram, I can see that I have a reflexive side in the center here. EF is part of both triangles. And then I can use my third angle theorem to show that the last 2 angles are congruent to each other. So now that everything is marked on our diagram, I'll start writing the proof. I'm going to start just by writing down all the givens. And our reason there is given. After we diagrammed all of our givens, the next thing we included on our triangles was that reflexive side in the center. So we said EF is congruent to EF. And our reason there is reflexive. The last thing we marked on our diagram was that last pair of angles. So that's angle DEF is congruent to angle GEF. And that is true because of our third angle theorem. So we've included everything that we marked on our diagram. So let's just double check our proof and make sure we have all the side statements that we need and all the angle statements that we need. So in our givens, I have 2 sides and 2 angles. In statement 2, I have another pair of congruent sides, so that's all 3. And in statement 3, I have another pair of congruent angles, so that's all 3 angles. So we did the thing, we showed everything we needed to show. For the last statement, we just have to rewrite our proof statement. We have proved that triangle DEF is congruent to triangle GEF. And we did that using the definition of congruent triangles. Okay, try the last 2 proofs and then check the answers in the completed copy of the notes that will be posted on Classroom.